This is the Spicy 100, question 2. Check out the moustache on that chili pepper. Pretty jealous of that. Right. The recommended time for this question is 6 minutes. It is a non-calculated question. So get your paper and pen, get your timer ready, and when you're ready to go, pause the question, and best of luck with this one. Question 2 is a sequences question. So what we need to do is establish what type of sequence it is, and we can use that to determine whether negative 169 would be a term in that sequence. So let's just write out what the sequence is. So we've got 2, 2, 1, negative 1, negative 4. So we can see it's decreasing. Now if we look at the differences between our terms, we've got 0, negative 1, negative 2, negative 3. So it's decreasing, and it's decreasing by 1 more each time. So you could say that the difference of the differences is negative 1. So this means we have a common difference of difference. Now that indicates to us that it is a quadratic sequence. So the logic behind this is if we consider the sequence for n squared. So n squared would be all the square numbers. So 1, 4, 9, 16, 25. Now if we look at the differences, 3, 5, 7, 9, 2, 2, 2. So the square number sequence has a difference of 2. So if ever you see a sequence that has that property, it generally means it's a quadratic sequence. Now using this logic, if we had half of n squared, we halved all of these numbers, then the difference of the difference would be 1. This indicates to us then that because we've got a difference of difference common of negative 1, that our sequence must involve a negative half n squared in it. So what we can now do is let's imagine what the sequence of negative a half n squared would be for our sort of first few values of n. So if we imagine n is 1, 2, 3, 4, just the first few will be fine. And so what we're going to do is we're going to sub in our values of n into this. So negative half times 1 squared will just be negative a half. 2 squared is 4 times negative half will be negative 2. 3 squared is 9 times negative half, so we can get negative 9 over 2. And then 4 squared is 16, so we get negative 8. So that's the sequence negative a half n squared. Now what I'm going to do is I'm going to write our original sequence underneath. So 2, 2, 1, negative 1. Now what we can see then is, so to get from negative a half n squared to our sequence, here I would have to plus or add 2.5. Here I'd have to add 4. Here I'd have to add, so it's negative 4.5 to 1 would be to add 5.5. And then here negative 8 to negative 1 would have to add 7. Now this is nice because we can see that actually the sequence that we get that we'd have to add on to negative half n squared looks like an arithmetic sequence. So we've got a gap of 1.5, 1.5, 1.5. So it's a linear sequence, and we know from we can find the nth term for this part of the sequence. So because we've got a common difference of 1.5, it's going to be 1.5n. So 1.5 times 1 is 1.5, so you'd have to add 1 to get to 2.5. 1.5 times 2 is 3, we'd have to add 1 to get to 4. And it works for all of them, so we just need to add 1 to this. So bringing this all together, so also 1.5 we could actually write as 3 over 2. So the nth term for the whole sequence will be the negative a half n squared, and then with the additional 3 over 2 n plus 1. So that would be the nth term formula for our sequence that we have. So now we just need to establish whether negative 169 would fit into this nth term formula. So if we remind ourselves of the nth term formula we just worked out, so nth term for our original sequence was negative a half n squared plus 3 over 2n plus 1. So if negative 169 is a term in the sequence, we should be able to equate these two together and find the value of n. Now the key thing is that value of n must be an integer. It must be a whole number. It must also be positive. So n must be a positive integer, or what we call a natural number. The reason being is n is the term number. You've got your first term, your second term, your third term. It cannot be a fraction, it can't be a negative because it is a natural number. So if we create an equation, so if we say that negative a half n squared plus 3 over 2n plus 1, and we're going to put that equal to negative 169. It creates a quadratic equation. So what we can do is we can remove the fractions, times everything by 2. So if we times everything by 2, we get negative n squared plus 3n plus 2 equals, so negative 169 times 2 is negative 338. Double check that. And bring it all over to 0. So it's a quadratic equation. I prefer a positive n squared, so I'm going to bring everything this side. So we get positive n squared, negative 3n, negative 338, and take away 2 is negative 340, and we get equal to 0. Now this is actually, 340 is quite nice to break down, so you can have 10 and 34. We can see that 20 and 17 multiply to make 340. So we can actually factorize this. So we get n, subtract 20, and n plus 17 equals 0. And from this, we can establish that n equals 20 would be a solution. But our value of n is an integer. It's a natural number. So n is a positive integer. So this implies that negative 169 is definitely a term in our sequence. We can also, now that we found that n is 20, we can actually double check that as well. So to verify if n is equal to 20, this would mean that our sequence would be negative a half times 20 squared plus 3 over 2 times 20 plus 1. So that's 400 times negative half, which is negative 200. 3 over 2 times 20 is 30 plus 1. So you get negative 200 plus 31 equals negative 169. So that works. So the term negative 169 is in our sequence. So I hope you felt good about that question. If you feel confident and you feel confident with quadratic sequences, move on and have a go at Spicy 100 question 3.